We're DukeMakers. I'm Henry. We're a composite of designers, innovators, and engineers who want to bring the best 3D printing practices to Duke. Having 3D printed before, we know that 3D printing is a direct translation from concept to direct physical prototype. With that knowledge, we know that 3D printing could completely reshape the manufacturing industry because of how accessible it is. And with that said, we want to work with Pratt to apply, develop, and explore 3D printing. But in order to be successful to do that, we have to create a vibrant and sustainable community of makers on campus. That is, we want to create a community that values open source learning and embraces 3D printing like we do. In order to do that, what we have been doing is reaching out to the community, and not just limited to Duke community. We have been reaching out to Durham, and Durham has been reaching back to us. We have actually traveled to other nodes of makers, and at the core of what we do is our projects, and we want to be as interdisciplinary as possible to integrate all 4 fields of Duke.
So what makes DukeMakers unique is our members, specifically the variety of members we have from different engineering majors. We have members who major in ME, CEE, BME, and ECE. And the reason we have such a variety of members is because of the unique project we have ongoing at all times from various fields. For example, for BME majors, we have the Biomesh and Prosthetic Hand Project. For the CEE majors, we have the Concrete Mold Project. And for ME and ECE majors, we constantly have new 3D printers that need to be printed at all times. And this sort of interdisciplinary approach is unique to DukeMakers, and what makes this possible is we recruit early in classes such as ME 221, Contact 201, and EGR 1 and 3, which is how I got involved in DukeMakers as a freshman. So currently we have 30 active members as part of DukeMakers and 200 members on the listserv. And these members meet weekly in their project build teams as well as during general body meetings.
So some of the events that we run 3D modeling tutorials as well as 3D printing tutorials. We also run the annual 3D printing challenge with Duke Collab, where students can show off what they've created and upload their creations to share with the Duke community. One of our biggest events, though, is going to the International World Maker Faire at New York City. At this Maker Faire, there's big companies like Microsoft, Intel, MakerBot, as well as universities and makerspaces from around the world that show off the projects they've been working on. And it's really inspiring to see just what these people have come up with. And next year, our hope is that rather than just going as visitors, we'd like to showcase some of our own projects at the World Maker Faire. And we'll talk about these projects in a bit.
So our club began earlier this year, and one of our earliest projects was getting a number of 3D printers. And early on we were committed to being economically sensible about this and getting students involved in projects and invested in the tools they'd be using later. So we opted to build printers out of kits, which was a cheaper option and gave students a chance to hands-on build the tools they would be using and understand the process, understand what goes into it. So that's currently ongoing, and the next step for that is to get them wirelessly connected so that you can print wirelessly from anywhere on campus. Another early goal we had was to collaborate with some artistic groups on campus and to bridge the technology and arts fields. And so to that end, we modeled the pieces you can see here for Form magazine, the campus fashion magazine. We printed out these original wearable pieces. And there were some other ones as well that were a whole array of pieces. And our next project is to design these artistic abstract lanterns for the 75th Pratt anniversary. And so we're opening that up to other members, and we have sort of a design collaboration contest. It's sort of an open thing to see what people can come up with, sort of abstract, organic, mechanical, interesting forms people can produce.
Cool. And so I'll talk a little bit about the biomedical projects we work on. 3D printing has a lot of scope in BME already, as you might have seen. So one of the most successful projects we've already worked on is the 3D printed prosthetic hand project. You can see Dylan over there in the corner. Me and Owen work on this project. And Dylan, as a 7-year-old child, his parents approached us with a problem. They said, hey, our son has a underdeveloped hand. He has difficulty picking up things and doing day-to-day tasks, getting a fully functional prosthetic hand made for a child is kind of not economical because the child's growing, right? So you'd have to like spend $10,000 on a hand, and then he grows, and then you change it. So this is a great problem for 3D printing because 3D printing is easily scalable. We can design a hand, and then just scale the parts up or down as the child grows, and reprint the hand for minimal cost. And so that's what we did. You can see him with the hand right there. That's actually the hand that we made for him that he uses. Even right now, he's using that hand.
Yeah.
So our goal right now is to keep moving forward with this project. Eventually, we partnered up with this open source prosthetics group called the Enable Group that maybe some of you have heard about. And the goal here is to produce eventually, we're looking at multiple avenues in prosthetics. So we're working with myoelectrics. Potentially we can make this a myoelectric hand if that's actually useful and more functional for the child. Right now, the way the hand is mechanically actuated, so he moves his wrist down and the hand closes. And so we're experimenting with a lot of different avenues. But eventually, we'd like to produce, a sub $100 kit that anyone can download the hand parts, print them off, get our Arduino code, run it on an Arduino, buy the servos, and then you just have a sub $100 kit just to make yourself a scalable prosthetic hand. And it'll be this open source project that we're hoping will really have an impact on the community. Some of the other projects we work on include the Biomass Project that Darsh will talk about.
Yeah, so one of our newer projects and ongoing projects is the Biomass Project. And we were tasked by Dr. Rossegard to essentially test this material he wanted to use for hernia repair. So first we started by researching different types of hernia, different type of meshes. And currently we are modeling these meshes in 3D modeling softwares. And we have finished those models. So the next step is to build a feel extruder to extrude the type of filament he wants and to test these meshes and eventually give them to him so he can test them medically.
So even though we've only been in existence for 2 semesters, we've already accomplished a great deal in forwarding our mission. For example, a meeting between DukeMakers and the Office of Information Technology seeded the plans for an experimental 3D printing space in the Multimedia Project Studio, which is located beneath Perkins and Bostock Library. This space was used so extensively that after just 1 semester of availability to students, 3D printing became an official service hosted by OIT, providing engineers an easy way to prototype parts or just to tinker, all completely free and without any restrictions. Additionally, since we want to have engineers who wouldn't otherwise normally join a academic student organization, we provide not only the space, the tools, and the logistics for their projects, but also the flexibility to base their projects around their own schedules, as well as complete choice in what kind of project they want to accomplish. Our ability to lower the barriers of entry for engineers to near zero throughout the semester encourages engineers to develop the skills outside the classroom and the lab early on.
So what do we need to make these things happen? Well, to run an active project space, we need resources and tools. And those are broadly 2 categories. One would be consumables. We need solder, filament, 3D printing filament. We need electrical components. We need the consumable things to work on projects. We also, need to make some types of investments, right? Like maybe we need a CNC router or a new 3D printing technology that we can keep in our makerspace to enable the projects, so that as our expertise develops, through the projects we're working on, we'll have the tools we need to, sort of make these things more production ready and, train people on the tools they'd be using in the real world to work on some of these projects. Ying's going to talk a little bit about the 3D scanning projects.
So 3D scanning goes hand in hand with 3D printing. It allows people to scan in real-world objects and directly map it into a 3D file available for 3D printing. And we believe that having such a project would not only lower the barriers of entry for members using our printers on a day-by-day basis, but also provide a fun and innovative way to draw in members who seek to join the makers movement.
And I also just really quickly wanted to mention some of the moonshots that people have been throwing out there, projects that are starting to gain a little bit of momentum. Things like an exoskeleton, like a pneumatic exoskeleton, or like I said, the myoelectric hand project is going places that we didn't really envision it going earlier. And so, having these tools and these resources really help us facilitate these kind of moonshot ideas. We want to have a space where people can come and say, hey, I want to do this, and we'll be like, great, we have the tools, we have the space for you to come work on this project. Go do it.
So all that said, we see a really bright future, not only for 3D printing, but also for our club. As 3D printing, the industry grows, we see a lot more students at Duke being attracted to our club, and we see a lot more opportunities for club growth and room to invest in really cool, exciting projects. So our goal here is really to make 3D printing at Duke as ubiquitous as 2D printing. So our philosophy is that makers will learn these theories in class and principles in lab, but they'll experience the realities of 3D printing in their everyday life. So you can imagine students waking up, creating these 3D models either through 3D scanning or on 3D software, and then using our wireless 3D printing network to print these objects that they can then use for really cool applications. So we see the future of 3D printing at Duke as being a really interdisciplinary endeavor that isn't just limited to Pratt, but crosses across all these different fields to the entirety of Duke, where we'll have collaborations between designers, developers, engineers, just students in general at Duke. And all that said, thanks a lot for your time.
Anybody have questions?
What sort of budget do you have, or how much are you asking us for?
So we're primarily asking EAC to fund some of our larger projects, namely the World Maker Faire trip, an open source 3D scanner, as well as Project Shape Oko, an open source CNC router. So this past semester, we've had tremendous success in hosting our first ever trip to New York City for the World Maker Faire. We sent around 23 members, and they had a chance to meet the best makers on the planet. So this upcoming year, in fall of 2015, we want to be able to replicate that same success with more members, being able to stay the full 2 days of the trip instead of just one, as well as having the opportunity and the time to just fully explore the Maker Faire and develop connections.
Can you describe a little bit of the value add of this group compared to, say, the space that's now available by some of your efforts, obviously, in the basement of Perkins? What's the value of this versus the space that's available there?
And the other space, there's lots of printers and scanners within Pratt now.
So what we have, yes, we have the technology, 3D printing, but what's more important is that we're building the community. I think without people, without skilled people, this sort of thing could never happen. And that's essentially the most important aspect of our club, is that we have a group of skilled people that know 3D printing and are really excited about working on projects like this.
And I'd also like to mention, we're not just 3D printing. That's kind of where we started. But where we've ended up is, sort of in a broader place. We're working on things like the myoelectric prosthetic hand, which involves a lot of ECE technologies. And so I suppose the value add that we have is we sort of have a space where people can come, hang out, grab pizza, toss ideas around, join projects that we already had a lot of momentum on and going with, and we can facilitate some of the types of projects that you wouldn't just be able to do if you just had access to 2 3D printers in the Perkins space. That's sort of we sort of have the value out of the community, other resources that go beyond just 3D printing and 3D scanning, and sort of just there's value in having a community, I think. And that lowers the barrier of entry to a lot of people, because you'll be like, hey, I'm going to the DukeMakers meeting today, well, you want to come? And you'll bring a friend over, and they'll sort of be in that community, be inspired, try out 3D printing, and maybe do something they might not have if they had a targeted plan, like I'm going to the makerspace in the MPS today in Perkins and Bostock, and I'm going to go print something. You might just be introduced to 3D printing in a more natural way. So.
I'd like to add that we see 3D printing as being, we see our club adding in the value of being able to really learn more about 3D modeling, 3D scanning, 3D printing. So the resources currently available at Perkins and to the engineering school, you use 3D printing as a resource. I'm just going to go print something for my other project, for my class, my NE class, for example. So in our club, we have people who are actually building 3D printers, open source 3D printers, and you really learn about like how a 3D printer works, how a CNC router works. We believe that members who have like this experience and this knowledge of how exactly to create a 3D printer and a CNC router, and all the other additional skills that we offer in our makerspace provide a value beyond that which other spaces can provide, just 3D printing as a resource.
Any other questions? All right, thanks very much.
Thank you.
Thanks.